So, welcome to another video from sickmaths.co.uk, where you can find lots of free maths videos. This video is about surds, that means stuff using square root signs. Here's example number 1. What happens when you square root 16 and then square it again? Well, square root of 16 is 4, if you square it again, 4 squared is 16. So come back to what you started with. But is that a surprise? Well, bearing in mind that square rooting and squaring are opposites, they like undo each other. It's like saying 16 divided by 5 and then times by 5. Obviously you're going to come back to 16 as well. So when you do opposites to each other, one after the other, you're going to get back to the same result. So, when I do the same thing, except for with 3 this time, so square root of 3, and then I square it, I should expect 3. Even though I don't actually know, or can't even write down completely what square root of 3 is, because it goes on forever. Yeah? So, it doesn't matter what square root of 3 is, I square root it and then square it. That means I'm doing opposites. It should come back to what I started with, which is 3. Same idea here. I've got square root of 5 times square root of 5. That's actually a hidden version of this, because when you times something by itself, you're squaring it. So square root of 5 times square root of 5 is actually square root of 5 squared, which should be 5 based on the same logic that square root of 3 squared should be 3. Now, these three ideas are roughly the same. Here's a new idea. Square root of 18 can actually be broken down into two other square roots. Yeah, and it has to be a product of its factors. So, for example, square root of 18 can be square root of 9 times square root of 2, because 9 times 2 is 18. And it can be also broken down into 6 times 3. So, square root of 6 times square root of 3, because 6 times 3 is also 18. So you can do it any way you feel like, as long as it's a product, or multiplies to make 18. Or whatever the starting number happens to be. So, but which one do I like the most out of these two? Or why do I say this one is good, and why do I say this one is not so good? Well, I like the fact that I can simplify this more. This one I can't do anything with, but this one I can. And in the next bit you'll see how useful it is to have it in this form. So the square root of 9 became 3, basically, and I couldn't do anything with square root of 2, so I just left it as it is. And you'll notice there's no times in between. That's what, as usual in mathematics, we get rid of the times quite often. It's like you say, if in algebra I can see something that says 5x, that means 5 times x, doesn't it? So I've automatically taken away the times symbol wherever I can. It just makes things a bit somehow neater because they're smaller. So that's that. So you got a choice of how you can break down a square root if you wanted to into further square roots, but we prefer to pick factors that are square numbers, because obviously if you've got a square number that's a factor, then you can actually square root it into a smaller number. Now, let's use that technique. So, number 5 says, square root of 90, take away square root of 40. Well, square root of 90 can be broken down into square root of 9 times square root of 10. And again, square root of 9 is equal to 3. So that becomes 3 square root of 10. Or times square root of 10. Or, even said shorter, 3 root 10. Because root 10 means square root of 10. So square root of 90 has become 3 root 10, and square root of 40, well, that's 4 times 10, right? There's different ways of doing it, but I like 4 because 4 again is a square number, and when I square root 4 I get 2. So square root 40 becomes 2 root 10. And so since I have square root 90 minus square root 40, it will become 3 root 10 minus 2 root 10. That is that, and that is that. Now, what is 3 root 10 take away 2 root 10? Well, I've got 3 of these square root 10s, and I've got 2 of these square root 10. And what I'm doing is I'm saying I've started off with 3, and I'm going to get rid of 2 of them, which leaves me with 1 of them. 1 square root 10, and that's the answer. That's the most simplified version. Let's try another one. You've got square root 90 times square root 40 this time. Now again, square root of 90 can be simplified as 3 root 10, and square root of 40 can be simplified as 2 root 10. So we just talked about that, but actually let's say that again. Let's explain how I did it again. Square root of 40 can be broken down into square root of 4 times square root of 10. Now square root of 4 is going to be 2, right? So then that means you can say you've got 2 square root of 10, which I've written here. Let's explain this one again. Square root of 90 can be broken down into square root of 9 times square root of 10. But square root of 9 can be simplified to 3. So instead of square root of 9 times square root of 10, I can just say 3 times square root of 10. Which is that. Anyway, that's the second time I've explained it, so hopefully that makes sense now. And timesing these together, I can do it in a special way. Instead of saying simply 3 times square root of 10 times 2 times square root of 10, which is what you've got, yeah? Remember, I've got rid of the times symbols between the 3 and the 10 and the 2 and the square root 10 there, yeah? So I can actually times in any order when I'm timesing. So that becomes 3 times 2, which is 6. And then I'll times the square root of 10 with the square root of 10, which equals 10. Because remember, if you do something like this, square root of 5 times square root of 5, that should equal 5, right? So in a similar way, square root of 10 times square root of 10 should equal 10. Then we times them together, because remember they're all timesing together. I've just times in a different order. So now I'm doing 6 times 10, which is 60. So what I'm saying is square root of 90 times square root of 40 is equal to 60. Okay, let's talk about the definition of an irrational number, because we're going to talk about rationalizing, which means turning an irrational number into a rational number. Okay, now irrational means usually something that doesn't make sense, and in this case it makes sense. It does not make sense to have a number that just goes on forever. So irrational numbers are numbers that are unending numbers. You can't write them down completely. For example, pi, you probably know, it goes 3.142, but it just goes on and on and on and on, and you can never write it down. So mathematicians call them irrational numbers, because it doesn't make sense that you can't write down a number completely. Yeah, it just goes on forever. And the same is true with so many different square roots. Square root of 2, square root of 10, I could have said square root of 5 or square root of 3. They all can't actually be written down completely. Okay, there are some square roots, obviously, like square root of 9, which equals 3 exactly, but those are only special square roots, i.e. square roots of square numbers. Yeah, so otherwise most square roots, yeah, you can't write down completely and are irrational numbers. Yeah, so when you say rationalize, that means get rid of the square root normally. Yeah, so let's do our first question where we have to rationalize the denominator. They always ask you to rationalize the denominator rather than the numerator. And so here's my fraction where I want to get rid of the square root from the bottom, i.e. rationalize the denominator. And what I'm going to do is I'm going to take my fraction and times it by root 2 over root 2. Which means I'm not really changing the number, because I'm timesing top and bottom by the same number, which is square root 2. Now, why would I times square root of 2 by square root of 2? Well, based on this idea, it turns into a whole number. So square root of 2 times square root of 2 equals 2. 1 times square root of 2 is square root of 2, but the point here is I've actually rationalized the denominator. There is no longer a square root on the bottom. Like this said, rationalize basically means get rid of the square root. It could mean get rid of, basically in general it means get rid of the irrational number, but in this situation always, almost always I suppose, it means get rid of the square root on the bottom, because the square root of 2 is an irrational number. So now it's a rational number. Right, so that's really simple stuff, but I really had to explain it in detail and nice just so it makes sense. So here we go, our last bit. This is also rationalizing the denominator. And what we're saying is, we've got a more complicated denominator this time, so we can't use that same technique, but we do use a fairly simple technique, which is based on this thing here. If you got a minus b times a plus b, it's going to become a squared minus b squared, okay? But what happens if we got square root of 6 times square root of square root of 6 take away square root of 2 times square root of 6 plus square root of 2? It's very similar to this pattern here, isn't it? You got a minus here and a plus there, and you got, you know, the same a there, and you got b's there. So you got sort of a minus b times a plus b situation, which means the answer should be a squared minus b squared. But what is a squared in this case? Well, if a is square root of 6, a squared is going to be 6, based on this idea here. And square root of 2 squared is going to be 2, so you end up with 6 minus 2, which is 4. Right, based on that, if that times that equals 6 minus 2, well, the same thing is true here. So I've got my same situation, a minus b times a plus b, where a is square root of 6 and b is square root of 2. So, which gives us 6 minus 2. I've already timed these together over here, except for I had them in brackets there, but it automatically has brackets when you're under a fraction like that. The whole thing is one whole piece. So anyway, so this times this equals 6 minus 2, which equals 4. And the top bit is really simple. I don't really do anything with it. I say 3 times this whole thing is just 3 times the whole thing, and I leave it like that. And I'm just happy that I've rationalized the denominator, as it says there. Okay, because the denominator has no longer got a square root on the bottom. And that is it.